On to number 4. Now, this one is very different, very unique. I get very excited about this one because this one isn't wastewater. So this is drinking water. Dr. Colin Ragish is the client manager on this one. Again, and this is different because at this stage we went to San Jose Water, we presented. So there's 2 chaps there. There's a chap, Adam Pfeffer, and Shaz Chan are the 2 people that we work with. Just amazing people, and the ability to take what we presented to them as a biofilm-based center or a microbial activity-based center and think a little bit outside the box for themselves and fit it into their specific problem statements was really fantastic. So San Jose Water, microbial activity monitoring. So when it comes to drinking water distribution, the key thing everyone wants to understand is, do I have microbial growth in this distribution system? Now, and how much disinfectant or how much chlorine do I have to add to repress or inhibit microbial growth in the distribution system? So, I mean, the status quo is I'm going to measure chlorine residual and I'm going to use that as my information to appropriately dose disinfectant. But the challenge is what you actually are trying to figure out is, do I have microbial growth? So the question for us and the question for Adam when we presented this was, well, actually, if your sensor can work in these environments, that's the actual information I really need. I really need to understand in real time when microbial growth is occurring or when it's beginning to occur, so that I can be more proactive, whether it's boosting or whether it's disinfecting and maintaining those low biofilm or that low microbial activity in the distribution system. So that was the question. Can a bioelectrode sensor provide that in situ reading, real time, all the time, always on, without any manual sampling? And can we use that to more to inform operators as to when this microbial growth or microbial activity is taking place? Now, with that, Colin, I believe I will hand over to you.
Yeah, so similar to all our other installs and similar to the last one I described at CMSA, we're looking at an installation that was in pipe, and you can see it there as a simply T-junction tapped into their typical piping, and then the sensor inserted. And it really was an afternoon to install it. And we've had some need for some visual inspections, specifically being a new application. We saw some interesting events regarding activity, so we've asked that they take it out and inspect it just to verify and validate what the sensor looks like in this new operation. You know, hopping into this data, the one thing you'll notice quickly is that the activity levels, that's the y-axis, is much lower than the other data we've shown so far today. So typically wastewater, we're looking in the hundreds of MET, and in a system like this, we're looking much less than 1. And again, as Pat said, the whole goal is to minimize microbial activity. And if we can minimize microbial activity, that will minimize the biofilm growth. And so what I've put on this graph is the chlorine residual, total chlorine residual, and that activity measurement. And we see that the chlorine residual is made quite well from March until about mid-April. And we do see some, spikes and decreases in residual, but it's a challenge in any distribution system that's large to maintain that residual consistency. And we do see some spikes in activity when these residuals drop, but early on, those are transient. So not a problem because we return to good control conditions. This all changed in April when there was a little more challenge keeping the residual up higher. And we saw suddenly that our baseline in activity increased a little bit. Not only did it increase, we started to see higher peaks in activity and longer duration of events. So we knew that something had changed biologically. There was more biological activity. So we believe that this one is when we really started to see a biofilm develop in here. And this presents a problem for the system, specifically since San Jose is using chloramines. They know that the development of nitrifying conditions is a problem. So we knew we've developed something, and then in early May there, we started to see a lot of rapid changes in activity, and that's unusual, and that tells us that something's devolving or unstable inside this biology. And it turns out what that appears to have been is one of these nitrification events. So when they get nitrification, they get rapid depletion of the residuals. And sure enough, that's exactly what we saw in this case. So if we move on to the next slide. What we've kind of defined operationally here is that we have really good control of biofilm, and we are able to maintain good residual conditions when we have activity that's below 0.05 MET. So we've placed alarms to start to warn us when this is happening. And if we see consistent spikes or regular spikes in activity over this, it's time to start to pay close attention to residual drops off and maybe start to investigate what is going on. And we know that when we start to see regular spikes above 0.1, we have significant concerns. We probably have an environment that could see a rapid depletion in chlorine. And so it's time to consider preemptive disinfection dosing or boosting. And what's really exciting here is that I think we provide the opportunity to improve our residual management in this last mile problem of disinfectant. And we think we can both increase our effectiveness of boosting, which isn't always effective in some of these situations, and we can also optimize our residual. So we can hopefully lead towards cost savings as well as a better product for the clients.
Fantastic, Colin. And you know, for me, because this is so different, like 95% of what we do has been wastewater, and to begin to move over into clean water. So we have a number of drinking water projects ongoing right now, and you know, watershed groups, so in lakes and areas like that. But the first time, I guess, we saw data showing the inverse correlation between microbial growth and residual. That inverse relationship to me is just amazingly interesting and makes sense. It just makes perfect sense. So it's great when data makes sense and is exciting like that. Okay.